Okay, let's go ahead and use that information to work some problems on this. All right, so if millimene means 1,000 and 1 milligram is equal to 10 to the negative 3 grams, or 0.001 grams. Kilo means 1,000, and 1 kilometer, kilo, tells us it's 10 to the 3rd meters, or you can say that is 1,000 meters. Deci means 1/10, so 1 deciliter is equal to 10 to the negative 1 liters, or 0.1 liters. Nano means 1 billionth, so 1 nanosecond is equal to 10 to the negative 9 seconds, and I'm not going to write that out in decimal. Okay, so what do we want to do this? We want to use our powers of 10, and we can utilize that to compare these. So to find out how much something is more powerful than others. Now this is really important. This is how they use things for the Richter scale and for measuring earthquakes and for the decibel scale. They all do it in powers of 10. So, you know, using this can be really useful. Okay, so when we compare 2 units, this is really important. We're going to take the larger divided by the smaller. And notice from the table, the larger units have the larger exponents. So we're always going to take the larger exponent divided by the smaller exponent. Okay, so how many hectograms? Let's see, hectogram. Hecto is 10 to the second. And megagram, and I'm just looking back up at my chart, is 10 to the 6th. So how many hectograms are in a megagram? Okay, well, let's see. So this is the same thing as finding out how many inches are in a foot. You take a foot and you divide it by 12. Okay. All right, so the larger is going to be, this will be the larger. This will be the smaller because of the exponent. So I have 10 to the 6th divided by 10 to the 2nd. And I end up with 10,000 if I'm doing it on my calculator. Or you can write this as 10 to the 4th. Your powers of 10, if it's a positive exponent, is just a 1 with that many zeros. Okay, so how many hectograms are in a milligram? 10,000. Okay, how many times larger is a millisecond than a microsecond? Okay, so let's see. A millisecond and a microsecond. So milli and micro. Which is the larger? The millisecond. Because -3 is closer to 0 than -6. It's a larger number. So that means millisecond divided by microsecond, which is that's the Greek letter. So that is 10 to the -3 divided by 10 to the -6, which if we do it in our calculator is 1,000, or you can say 10 to the 3rd, okay, if that makes more sense to you. So a millisecond is 1,000 times larger than a microsecond. Okay, a kilometer is how many times larger than a millimeter? Okay, so I'm going to have to go back up to, and we know that kilometer is bigger, so we're going to do kilometer over millimeter. So a kilometer is 10 to the 3rd, and a millimeter is 10 to the -3. which gives me 10 to the 6th. So it is 10 to the 6th times larger, or I can write that as 1 million. Okay. And again, hopefully you are doing this on your own. A hectoliter is how many times larger than a liter? So we're going to do hectoliter divided by liter. Hecto, I'm looking back at my chart, is 10 to the second. And you can either use 10 to the 0 or you can just use 1 from the table, which is 10 to the second or 100. Okay, so that was pretty straightforward. The only other thing I want to talk about in this unit is I want to tell you what density and concentration are and how they're used, and all we're going to do is an example on density. Okay, density is generally used to describe compactness or crowding. The units depend on the context. Okay. Usually density is applying, they're doing the census this year, and so that's one of the things that they want to find out is the population density in an area so they can figure out what kind of services and that sort of thing are needed. Something that you may see every day if you watch the news when you look at the allergy count. That is always based on how many particles per whatever. I don't know what the details are on that. But that's what the density would be on that, is how many particles of the particular allergen that are available in the air. It's different for every allergen, whether it goes into low, medium, or high. Okay, so you can deal with it in terms of population if they want to find the density in the deer population, whether you're from a hunting standpoint or, whatever standpoint. In medication, this is really important. The density, you need to find the milligrams per kilo. So that's very, very important. All right, but mostly we just do it for, kind of whatever. So let's start out here with the population of Manhattan is 1.6 million people living in an area of 57 square kilometers. So, and this is going to, notice there is the word per in each of these, which means we are going to divide. So we are going to do people per kilometer. So that is going to give me 1,600,000 divided by 57 kilometers, which gives me approximately 28,070, and that is going to be people per square kilometer. Oops, and I forgot to square it since it's an area measure. Now, to take us into something that we did in our last lesson, now we're going to have to take this, and they want to know, because that doesn't, for those of us Americans, that's absolutely meaningless to me. So I want to know what is the density per square mile. So that means I'm going to have to take this kilometer and I am going to have to convert it to miles. So I am going to start, and we'll just use this, with 28,070 people over 1, and that is going to be people over kilometer times kilometer, which is our kilometer squared. So that means I'm going to have to do a conversion twice with kilometers on top, because I need to get that into miles. And notice miles is abbreviated MI because M means meter. Okay. So you can use either one that you want. I am going to use the 1.6093 kilometers is equal to 1 mile. 1.6093 kilometers is equal to 1 mile. Now, the reason I did that is now I've got rid of my kilometers, but I don't have to divide by anything. So if I get my calculator out, I'm just going to do 28,070 times 1.6093. Whoops. And I get approximately, and that means approximately, not equal. Let's round up to 72,697, and that is going to be people per square mile. Now you may want to look at this example in your book. This is something, what is your BAC, your blood alcohol content? How do they determine whether, if you're out and you get stopped, whether or not you're drunk? And it is based on a concentration, how much alcohol is in your bloodstream. And I think you would be surprised if you do this. I will tell you that the answer to this is, if I'm not mistaken, I don't remember if it makes you legally drunk or not, but it doesn't take much. So be careful out there. Okay, we're done. Thanks.